Hey everyone, welcome back. This is RAD103. This is Module 3, and this is Lecture 2.3. And so we're in the middle of talking about contrast resolution. And we're going to start off by talking about post-processing. So this is after your image has been developed and it pops up on your monitor. Can you make adjustments to the contrast? Yes, you can. So when we see our image pop up, we are able to adjust the contrast by using something called window width. So software allows us to grab our mouse in a certain part of your control panel, and if you go back and forth, left and right, that is considered your window width, and that will change the shades of gray. And that will change it from a high level of contrast, so you'll see more blacks and whites, and then you can drag it to the left or right, and then you'll see the contrast drop, giving you more shades of gray. And so you're able to window width or move that mouse left and right, and you're able to see differences in the contrast, which should help you identify and see things in the image that maybe you didn't see before. So that is window width. The other term to discuss, which is like window width, is window level. So if I took my mouse, if I'm in that software package on my control panel, and I take my mouse and I go up and down, usually it's up and down. Up and down means its brightness. So it's going to change the window level, which means it's the pixels, the brightness of each pixel on your monitor. Now, by adjusting both the window level and the window width, so if you took your mouse and just kind of did a circle with it, you're going to see all sorts of changes. The shades of gray change and the brightness of each pixel changes. And what it's doing is it's helping your eyes and your brain visually distinguish certain parts of the anatomy that you're looking at a little bit better. And so this helps a radiologist determine certain parts of the anatomy that maybe were obscured before or difficult to see with the original set of contrast values. But now by changing the window width and window level, you might be able to draw those things out and be able to see them a little bit better. Now, I've mentioned before that if you change your window width or your window level, you decide to change the contrast, your image doesn't come out so great and you want to see if you can make it look better. Most of the times, of course, you're going to be able to make that image look perfect. But I'm urging you not to save those values. The reason why is because if you save it with those new set of values, you've just limited to what the radiologist is able to do on their end. If you give them the original set of data points and you send it, even though it looks lousy, they have the whole window width, they have the whole window level to play with. But if you've saved it in a different spot, they're not going to have as much leeway or latitude to make changes to the image. So if you can fix it on your monitor, that means they'll be able to fix it on theirs. And even though it looks lousy, I would still send the original data set over to them and just learn to take a better picture next time. So I want to mention latitude real quick. Latitude is how much leeway you have when you're making an X-ray image. If we're using film, there was very limited latitude. You had to have a specific technique, KVP and mass, and it had to be right for that person's anatomy, the size of them, and whatever it was you're X-raying. There was very little room for error. With digital, we have a lot of latitude. We have a lot of things that can kind of save our bacon if we use the wrong technique. Software that we use, and the digital values of each pixel, all of the shades of gray that we have, allow us to kind of make up for the fact that maybe we took a bad picture. And so digital X-ray has great latitude, and that allows us to fix an image even after processing, which is a great thing. I also mentioned latitude because if you're ever playing around with the software on our CareStream system, yes, there's a way to window level, but they also have a feature where you can go and change the latitude. And so changing the latitude actually kind of adjusts this curve that is kind of behind my screen here, or below it, this part here. You can adjust that. Something with more latitude won't have such a steep curve. It'll be a little bit more horizontal. And so it just changes the shades of gray just enough and allows you to play with the image a little bit more to get the visual features that you're hoping to get. And it should make certain anatomy pop. It should make any type of artifact in there kind of stand out. But it's a way of adjusting the latitude. So I just want to mention, if you see a question with regards to latitude, it's just it's usually associated with the fact that digital has a high DQE, detective quantum efficiency, and we have software that allows us to make changes to the image after it's been processed, which gives it a lot of latitude. So that's what it's referring to. If you have any questions about this, let me know. Now, the reason why there's so much latitude is because we can still make changes after our image has been processed. With film, you didn't have that capability, so very narrow band of latitude. But because digital imaging allows you to make those changes, it is visually graphed as a linear diagonal line, showing you that on the very bottom left, you're going to have whites, and as you slowly work up your little linear graph, you get into darker and darker shades of gray until you finally get to black. But all of those shades of gray are available to be used with the pixels that we have in our image display, because we can window level. So even shades of gray that we can't even detect with our eyes is going to be able to be shown through these digital pixels. And so because of that, because of the linear faction of the image response function, because of the shades of gray that we're able to change, it has a very wide latitude. So that's what it's referring to. So to kind of put this in practice, I know what I'm saying is a little nebulous, but what I'm saying is if we have these images here you've got chest x-rays, chest x-ray A is underexposed, chest x-ray B is got nice contrast, that's acceptable, that's what we're looking for. And image C is overexposed. You can see that there's oversaturation of the plate, is very, very dark. And I will be mentioning this, but these like double mountain graph that you see is called a histogram. And every piece of anatomy has its own individual histogram. So all chest x-rays will look similar to this. Wrist x-rays will have a designated histogram. So they'll have their characteristics that look like a wrist, hands, feet, whatever you have. You'll have different shape histograms. But this is the histogram for a chest. And as you can see, if we go back to the old-fashioned logarithmic response function of film, I mentioned that the important, or the shades of gray that we care about, are in the straight line portion. And so what we can see here is that these values, these pixel values, are down here, which is all whites. Up here is all blacks. And so the majority of our pixels are showing that they're too white. They're too far to the left here. And so how do we fix that? Well, if we could just take this graph and pull it this way, we would then be able to put that and make it ideal. You can see here how the shades, the different peaks and valleys of our histogram fall within the straight line portion of our logarithmic curve. And that is the butter zone. Those are the shades of gray that we want in our X-ray image. This is too light, this is too dark. So you can see this histogram is too far over to the right. It's in the dark area of its little graph here. Here's the straight line portion. I want that straight line portion to be right in the middle of my histogram, and I would get this shade of gray. And so that's what, in essence, the computer's doing, is it realizes that everything here is good, but it's all too light. So let's pull this over. This is perfect. Leave it the way it is. This is too dark, so we need to take this and pull this over so we see it. And that's what we can do here. And so you can see how it has adjusted or made the changes to the pixels or to the development. And so it just grabbed this red line. The straight line portion should be right over my histogram. It moved it over. This was already perfect to begin with. This one was too hot. This one's too dark. Pull it over. So this is just showing you how the computer is using its algorithms and its software and its latitude to make changes. And so despite the fact that we might have had a wrong technique or our image came out poorly, it has the capability of adjusting those pixels so they fall in the right places, and we're using the right shades of gray to get exactly what we're looking for. All right, guys, and with that, I'm going to wrap up. So that takes care of contrast resolution. In the next video, we'll be talking about spatial resolution. See you in a little bit.